512, logarithms and equations. So far the only logarithmic equations, or the exponential equations, that we've been able to solve had a common base. For example, if 2 to the x is 32, and if you know that 32 is 2 to the 5th, then you can say, well, then that means x is equal to 5. Okay, and then that's the answer to that equation. Nice, clean solution. Well, what happens if you can't find that common base? So 2 to the x is 36. Well, if 2 to the 5th is 32, then 2 to the 6th must be 64. And so there's no way to write this as a base 2. Well, that's one of the reasons people came up with logs. Because if you take the log base 2 on both sides, then as long as this 2 and that 2 match, then you get an x on the left, and you get a log 2 of 36 on the right. And that is exactly what the answer is going to be. It's just not as nice and neat, as the answer that I have over here. Okay? But that's what logs were intended for, to be able to, find the exponent here by taking an inverse and undoing, the base 2 exponential expression. In general, when you solve these, you have to keep basically two things in mind, other than the normal rules that we use for solving equations, and that is that you really have to isolate the exponential base first. So that means in this case, for example, 2 to the x plus 4, well, the plus 4 needs to move. I need to subtract 4 on both sides, and then I need to write 2 to the x is equal to 5th, so that it's just the exponential base here. And then, same story as earlier, as the example above, that if you have a log base 2, and as long as these match, then you can get an x on the left, and then on the right side you end up with the answer. So there's your answer, x equals log 2 of 5. Okay, over here the exponential base is isolated, so we can immediately take a log 7. So if we take the log 7 on both sides, and again, I'm going to rewrite it once this way so that you can see. So this base and that base match. Then you just get 2x minus 1 here. And then on the right, you would get the log base 7 of 9. And then, it's like solving a linear equation at this point. You got to add 1 on both sides. So if you add 1 on both sides, you get 2x equals. Now, I wouldn't put the plus 1 here because now I'm not sure, is it 9 plus 1? So it's 1 plus the log 7 of 9. It's a little clearer in terms of communicating. And then the last step is to divide by 2 so that you get rid of that. And you can just leave it this way. Okay, it's not a horrible looking answer. But at the same time, I don't really know how much this is going to be either. Okay? Alright, last one. So a plus 4 here, a negative 4 here, so, add 4. Then you get 3 times 10 to the power of x plus 2 is equal, that's a large x, parentheses, is equal to 36. This 3 is multiplying the base, so divide by 3. Then you get 10 to the exponent of x plus 2 is equal to 12. Match the base with the log, so match the log base with the exponential base, then you get x plus 2 here. And then on this side you would get the log 10 of 12. And then keep in mind that we would not be writing the base 10 here, or you don't need to. It's not wrong if you do, but I'm lazy. So, and then one step left, take away 2 on both sides, and then you have an answer. And again, that's not an answer that I'm real comfortable with. Okay, but that's the right answer. Okay, so all of these are acceptable, and the problem is, though, that sometimes we'd like to sort of know, well, how much is log 2 of 5? Or how much is 1 plus log 7 of 9? And, well, actually, this one, we should be able to figure that out, right? Because most calculators have a log button have a log 10. So that one I can figure out. So let's see what that one is. So that one said it's a negative 2 plus the log of 12. Close the parentheses. So that one was a negative 0.92. Okay, But these I cannot even put in the calculator. Like something as simple as log 2 of 5, I don't have a calculator button that allows me to do a log 2. Like, that's the log 2, and then there's no of 5 button, so you can't do that. Although, if you do a little research and if you just try it here and there, try one, there are a lot of calculators that actually will allow you. Now, I found this one, and it's sort of hard to see, but it says here logarithm of number x to base 10. So, for example, if you just type in the number this way, then this is telling you here that's the log 10 of 100. Okay? But for example, if I wanted the log 2 of 5, I could do this, the log 2 and then of 5. Did it backwards, did I? Yep. So see how it's changing the expression here? It says, what does it say? Log x or base y log xy. So what's the base that I wanted? There it is. So apparently I needed to swap these out. So it's not quite as easy. You got to figure this out a little bit on your own. You end up with an expression here. So the log 2 of 5 is apparently 2.3ish. Okay, so there are calculators that will let you do that. So here we could say this is about 2.3, which is, we probably could have come up with something pretty close to that, right? Because 2 squared is 4, and 2 cubed is 8. So to get 5, I got to be a little bit past 2. Okay. You also need to be able to solve these problems by using a common log or a natural log, though, because that will allow you to find the answer with any calculator. So not specifically with a calculator allows you to change the base. So how would you do that for this one? So we just sort of plug this in. So I know I'm supposed to get about 2.3 there. Okay. So let's redo this one, and we'll change it. At this point, we'll change the problem slightly in terms of our approach. Okay. So usually, if I just want to know what x is worth, but I don't really care what the decimal is, I would take a log 2. Well, what happens here if you take a natural log? So I'm going to use a natural log because I'm lazy, and the common log would be 3 letters, so natural log is shorter to write. If I take the natural log on both sides, okay, then the exponent still comes down. But it leaves me with the natural log of 2. And on this side, I would end up with the natural log of 5. Okay, so now it says x times ln2 equals ln5. So this is multiplying the x. So if I divide by ln2 on both sides, I should be able to get my answer. So why would I do this again? Well, what if I only had that first calculator, the one that didn't allow me to change the base? Is x equal ln5 over ln2, is that worth the same as on the other calculator? So this is what we're supposed to get, 2.321928 blah, and then some other stuff. Okay, so how about here? Do we have a natural log button? Yeah, right there. And so it says the natural log of 5, right, close your parentheses, divided by the natural log of 2. And how much is that? So we get 2.321928. 321928. Here's the other one, 321928. And you can see it's the same number. Okay? Alright, so let's do a couple more of these where you have to somehow take a log that allows you to put it in the calculator as either a common log or the natural log. So, where's my... Sorry, just lost my cursor for a second. So 2.322 was the answer. Okay, so on this one, we'll use a log base 10 on this one. Okay, so if I use the log base 10, then the 2x minus 1 still comes down. Okay, but now it's an exponent, and on this side I would have a log of 7. I am going to be somewhat lazy here, and then here I'd have to take the common log as well, so I get a log 9. Okay, now I'm really interested in what the x is. So to get x completely by itself, I'm going to have to distribute this first. So I have 2x times the log of 7, okay, keep in mind that's a base 10, minus the log of 7 equals the log of 9. Well, add log 7 on both sides. So here I'm going to add log 7. Okay, so that leaves you with 2x log 7. And you cannot add these. Okay, so just leave it this way. And then let's see, the 2 is multiplying the x, but so is the log 7. So both of these are multiplying. So if I divide by 2 and if I divide by the log 7, then I should just get x. And that's exactly what I will need to put in my calculator. So this is then my final answer. So this is the actual answer is log 9 plus log 7 divided by 2 times the log of 7. Because keep in mind I'm dividing by 2 to get rid of the multiplication here, and log 7 to get rid of the multiplication there. And then you should be able to put that in your calculator. So if you put that in your calculator, what x do you get? Okay, so I'm going to go back to the calculator one more time, if I can find it. And not that one, because we're pretending we don't have that technology a little bit. So how do you put this in? Well, in the top for the fraction, it said the log 9, close your parentheses for the log, plus the log of 7, close your parentheses for the log 7, and close the parentheses for the top of the fraction. So that's the top of the fraction, log 9 plus log 7, divided by, and then parentheses again, 2 times the log of 7. Close the log and close the parentheses. And so that's 1.065. Okay, the parentheses here around the 2 and the log 7 are important. Okay, the parentheses in the top are easy to see. Most of you guys will be fine with that. So keep in mind it's supposed to be 1.06. So if you do log 7 plus log 9, close to double parentheses, and then divide by 2 times the log of 7, and if you hit enter now, you will see you get a much different answer. You get 0.76. That's not right. Because really what's happening here is taking this quantity, so it's adding these two, then it's dividing that by 2, and then multiplying that by the log of 7. Okay? So please be very careful with this. So the correct answer should have been 1.065. Okay. A couple more examples. Alright, so how about this one? Well, this works great, because if that's e to the exponent of x and 9 minus 4 is 5, and you're matching your base with your log, so the natural log here matches. So you actually get e here. So the answer is ln 5, and you can put that straight into the calculator. So that's 1.609. So that one was great. That also works here. If you take the natural log, since the bases match, I don't have any weird stuff going on. So, add 1 here. I get 2x is equal to 1 plus the natural log of 9. Divide by 2, and that's your final answer. Okay, now on the calculator, this one's a little trickier, because keep in mind you have to use this. Parentheses in the top. And if you do that right, you should get 1.599. Okay, so now let's look at the last one. And I changed it a little bit, I think. It used to be a 10 here. So now what if that's the base 2? Now what do you do now? Well, first you still isolate. So we're going to do plus 4. Not dividing by 4. We're supposed to do plus 4. So then I get 3 times 2 to the negative t is equal to 1004. Then divide by 3 to isolate the exponential expression completely. And then you need to match this base with this base. So if you do this, you're going to end up with a calculator answer that might be difficult to do, right? So if you do this, then these match, so you get a negative t is equal to the log 2 of 1004 divided by 3 as a quantity, and then think of that's a negative 1, so divide by a negative 1. So that would be your answer. It would be, it would be t equals the log 2 of 1004 divided by 3. Now that whole thing was divided by a negative, so that just puts a negative over here. Well, that's one way to solve it. Okay, and if I just say solve, then I would do this. Okay, so if I just say solve, just leave these answers. Those are the most accurate answers you can give me. But if the problem says solve and approximate with a calculator, then once you get to this spot where it's used to say 2 to the negative exponent of t is 1004/3, you have a choice to make. You either take a natural log or a common log. Again, I'm lazy, so I take the natural log. So I get a negative t times the natural log of t is equal to the natural log of 1004 divided by 3. Divide by ln t. So I get a negative t, so I'm going to divide by ln, sorry I said ln t, I meant ln2. So I'm going to have the natural log of this number, and then divide that by the natural log of 2, and then the negative just moves to the other side, so this can go into my calculator. Okay, so that expression can go into the calculator. So let's see what that is on this one. So that's the last one that we'll do. So on the calculator, it would have been, let's clear this first. So it's a negative, and the top one says ln, and then inside I did have brackets there, so it was 1004 divided by 3, close the brackets of division, close the brackets for the natural log, divided by the natural log of 2, that's a little friendlier to work with, and so it's a negative 8.387. Negative 8.387. So that's the calculator approximation. So I should have a little squiggly here. That's the actual answer is right here. That's the most accurate answer you can give, and then the calculator approximates it to a little more than a negative 8. Okay? Thanks.